Hi, my name is Ivy and I'm in the Calculus Spring 2017, and this was for Test 2. I got problem number 8 wrong, and it was about the acceleration of the calculator upon impact. So I'm going to go over a little bit of my thought process. So I was really trying to focus on the equation, and I think I was more like trying to think back to some of the examples we had, and maybe I was just thinking I was going off those examples, but I really wasn't. So the first one is the position equation, and I wrote down the equation exactly as up here, but I set it equal to 0, and I know that was a little too early, and that should have actually been when I substituted in. So the position equation I got wrong because I didn't already substitute the variables, which I should have. So I should have substituted the v, which is the velocity, for 0 because the object is free falling. And then I should have substituted the s for the 3,240. And then that would have been right. So the position equation was basically, you kind of just plug in the numbers, so you substitute them. And then I knew that the velocity equation was the first derivative of the position equation. So I got the first part right because I did do the derivative of the negative 15t to the third. So I know I got that part right, but then I substituted. So instead of substituting the first time, I substituted the second time, and that's why I got both parts of those wrong. And so I got the acceleration right because I knew that it was the second derivative of the position function. So whether I substituted then there in the position or the velocity, I still would have got the same derivative. So that's how I guess I kind of coincidentally got that right. So yeah, I guess my thought process was more, you have to do the equation for the position and then you have to substitute, but I now see that that is wrong. So in my video, the next part of my video, I kind of go into detail and explain exactly what my problem was and how to fix it.
I was like, I don't even know what that is.
So my problem is problem 9 that says, suppose the function of the free-falling object on planet Hoffmanite is given by, and it has the equation, an equal calculator is dropped from the top of the tower at 3,240 feet. Determine the acceleration of the calculator upon impact. Okay, so the first, here's the original equation. And this is the position equation. Okay, so that's the position equation, but we need to determine the acceleration. And so in order to get the position equation, we need to use this. And we have negative 15t, and it says that the velocity is 0, so this is 0, but the position is 3,240. So that is just reduces and gives you a negative 15t cubed plus 3,240. So this is your position equation right here. We need to get to acceleration. So in order to get to acceleration, we do the velocity, which the velocity equation is just the derivative, the first derivative of the position equation. So when we do that, we get negative 45 t squared plus 0. We just basically do the derivative, so times 15 by 3, and you get negative 45, and then you have the exponent to 2. The derivative of that is 0. So we have the velocity equation, and so now we need to find the acceleration equation. An acceleration equation is just the second derivative of the position equation. So you get negative 90t. But that's just the equation, and we want to know the acceleration of the calculator upon impact. So in order to do that, we need to find the time it takes for the calculator to reach the bottom. So all we do is we take the original position equation, which is the negative 15t cubed plus 3,240, and we set that equal to 0. And then you, of course, subtract, so you get negative 15t cubed equals negative 3,240. You divide by negative 15 on both sides. And so that gives you t cubed equals 216. You then cube both sides, which gives you t equals 6 seconds. So there we have the position equation, and we get the time equals 6 seconds. And then we plug that into the acceleration, which is, like I said, the second derivative of the position, and you get negative 90 times 60. You can put 6, or times 6, so you can put 8 and put the time, which is 6, and do negative 90 times 6, and that gives you negative 540, and then that units is feet per second squared. So this is your final answer. You first have to find the first derivative and the second derivative. The second derivative is the acceleration equation, and you set the position equal to 0. You find the seconds, and you plug it into the acceleration equation, and that gives you the answer.